case. And then I'd love to field as many questions as we can at the end. So I'm going to get started. Essentially, Tintri was founded by the former VP of Engineering from VMware, Kieran Hardy. Kieran's big sort of idea behind Tintri came from actually a lot of the early growth that VMware had as a company. They were essentially growing, gaining market share. People were virtualizing more and more. And amidst all the success that VMware was having, he actually saw that at some point they started reaching a virtualization stall where companies, larger companies, were actually having a problem virtualizing more of their infrastructure and doing it at a pace that they wanted to. And when he dug into the issue, it really became clear that traditional shared storage was sort of becoming a bottleneck for customers to virtualize more and virtualize quicker. It was either very, very complex or very costly to do so. So after kind of thinking about this, his brainchild was essentially, let's build a purpose-built storage platform from the ground up specific to virtualization. And that's really what Tintri is. We are a storage company, yet our mission is really completely focused around virtualization. Our goal is to help our customers virtualize more and do it faster than they ever had before. We have been around since 2008 was when we were founded. We've been shipping product for over a year. We've had tremendous growth in our first year of shipping product, and we're already spun up across the globe. So we're busy in North America, throughout EMEA, and Japan as well. Specific to VDI, right? So our focus is all things virtualized, but VDI seems to be one of the most discussed topics I have, at least with my customer base now. And usually they're coming to me and saying, we've been trying to do VDI, or we had a VDI POC, and it's fallen off the tracks, or it's stalled, or it's just flat out failed. And they usually come to me with 2 or 3 of these things being the problem. They're either saying, we can't really justify the cost. We can't wrap our arms around what we're going to do to sell this up the chain to management. We know we want to do it. It's just a struggle. And that usually is due to the storage cost, the underlying infrastructure it takes to actually get a VDI scenario going is expensive. And this is really due to something we'll talk about later, in that in the physical world with one computer, you have one dedicated disk to one operating system, and now the nature of consolidation, you're trying to service hundreds or maybe thousands of virtual desktops off of some more expensive enterprise-class storage that can prove to be a challenge from a dollar per desktop standpoint. Often this also leads to a performance problem, and people end up having to over-provision disk in order to get the performance they need, again, which goes back to the cost scenario. The other part is just pure complexity, right? The standalone desktop has been around forever. It's simple. It's sort of a, my first job in the industry was desk side support, right? It's one of those things you kind of wrap your arms around and master first. But the complexity of VDI is interesting because it's actually different than just general server virtualization. We're accounting now for concepts like link clones and storage pooling and connection brokers. And then under the covers, the storage piece is also fairly complex, right? We've got to traditionally tier out our storage, put replicas in one place, linked clones in another, the user data disks yet somewhere else. The bottom line is there's multiple moving parts. And when my customers come to me, they basically say, you know what? Storage is being blamed as that thing that's inhibiting us from really succeeding in virtualization from either a cost, a complexity, or performance standpoint. And that's something where we've been able to be very, very successful in helping our customers get their VDI projects either off the ground from being stalled or into a fully, production type state. Really, what's interesting is at the heart of all things virtualized is storage, right? You can't really do any of these clustering, high availability, DRS, vMotion type functions without true shared storage. So we know that at the foundation of all virtualization, specifically VDI, is right-sized, right performance shared storage. So obviously the storage story has to be correct. Interestingly enough, though, one of the biggest hidden costs we alluded to earlier is storage, and this is simply due to the nature of consolidation. From going from, one, virtual disk per, or one physical disk per physical endpoint to now having thousands of VMs trying to access a shared pool of disks. Typically, you're either having to over-provision or buy some sort of enterprise class super expensive storage to do this. Over 60% or around 60% of the typical virtualization infrastructure budget goes just to storage. And this doesn't lend itself well to fitting within the CapEx and OpEx goals that VDI promises long term. It's one of the struggles we've seen. Underneath this is also complexity, right? And we talked about this before, but really the way we have provisioned hasn't really changed much, right? The hypervisor brought us great drastic change in the way we manage compute, right? Resource pooling, being able to elastically and flexibly and agile give resources to different workloads when they need it. It's completely changed the way we look at x86 servers and how to manage them. But really underneath the hypervisor, storage hadn't changed all that much. We still grabbed a set of disks, created a RAID group, carved a LUN out of them, presented that up to a host, or a cluster of ESX hosts, formatted it with VMFS, and in the end we have a data store. And this really kind of led us down the path of manually tiering out our storage, right, where we would put gold, platinum, silver type data stores in place, and then based on that, put the appropriate workload on. So in the case of VDI, we might put replicas on a data store that deals with reads very, very well, and the linked clones on a data store that deals with writes very, very well, and then user data disks would go somewhere for large amounts of capacity or something with a really great dollar per gigabyte, and you're purposely architecting. And it's also a bit inflexible. If you're off or your calculations kind of don't line up right in the end, you may have built an infrastructure that didn't fit your workload. So it's not only complex, but it's a little bit unforgiving as well. And then obviously there's the performance piece, right? VDI in and of itself is a very different characteristic in terms of its read and write patterns than that of general server virtualization, generally due to the bursty nature of VDI. We factor in things like boot storms, antivirus storms, logon storms. That's one type of bursty type workload. But then there's also things native to View Composer, refreshes, rebalances, recomposes, where you're actually changing the underlying disk. And those also have some bursty nature to them. So it's not only important to plan for steady state in your VDI environment, but it's also key to plan for those bursty periods because those directly impact end user experience. And one of the biggest killers of a VDI project is end users complaining that, hey, my screen's lagging. When I click my mouse, nothing happens. I want my physical computer back. One of the things we really need to assure is that that end user experience is as good or better than it was in the physical world. And really understanding the storage aspect is paramount to this. We certainly are trying to avoid the mismatch at the storage layer, where previously you had one desktop, one SATA drive, was giving all its I/O dedicated to that OS, and now we're trying to service hundreds of thousands of desktops off of some aggregate of disk underneath. Latency becomes extremely important at this point, and it's one of the things that we know we have the answer to. So really the question becomes, right, what if the storage underneath truly understood what a VM was, what a virtual desktop was, and what resources it needed, and at what time it was going to need those? And that's really the Tintri story, is the purpose-built approach, both from a performance standpoint, but also from a virtual machine workload visibility standpoint. When you look at the three things that we're most often complained about, we actually think with Tintri we can enable VDI. We can actually be the enabler, not the inhibitor, for virtual desktops. So from a cost standpoint, density is one of our great capabilities where within a single 3U appliance, we have the ability to get hundreds, 5, 6, 7, 800, even up to 1,000 desktops in a single node. Every time you get denser, that dollar per VM, that dollar per IOP keeps getting better. So you're basically increasing your cost savings as you scale. What's also nice is because we do away with some of the physical storage world constructs like LUNs and volumes, we don't have to suffer some of the complexity and scalability problems that traditional shared storage has. We manage and monitor everything at a VM level. So we'll natively understand and recognize and manage at the VM and vDisk level, which gives you basically direct insight into your virtual machines. So when you do have that end user call, say, hey, my workstation is acting up, it's slow, it's lagging, we can basically pinpoint right to that specific virtual desktop and find out, what is this issue due to? Is it a latency problem at the hypervisor level? Is it on the storage network? Or is it actually a disk-related latency problem? And what's nice is we don't get involved in some of the caching or tiering models. We certainly leverage SSD, but we do it in a very different, much more elegant, much more simple way than caching or tiering, which really allows us to solve the performance problem very simply and gives us a fair amount of flexibility. What I really mean by this is one of the design goals of Tintri was to service 99% of all reads and writes out of flash and do so with sub-millisecond latency. This is huge for VDI because of that bursty nature of the workloads. So all of a sudden you have 300 people try to boot their computers at the same time, or that antivirus storm kicks off, or you're doing a recompose to update a base image, you're going to have all of a sudden a giant burst, a giant request for I/O. And if you're increasing latency at that same time, the other workers that are already using their desktops are going to suffer. So we're able to basically take that big I/O hit, service almost all, 99+% of it, out of flash, and do so with a sub-millisecond response time. And this is really why, with us, helping move that bottleneck becomes the enabler for VDI. This is where we've kind of seen some of our customers' stalled virtualization projects really get off the ground. They get out of their POC phase, and they finally get into actual production, real users using this. For a quick review for those who don't really maybe know exactly what a Tintri appliance is or looks like or does, you can think of one node, and you can see a picture of it back there behind the monitor. Think of the 3U appliance. One node effectively is a VMware data store. You can think of it as a data store appliance. Besides that design goal of servicing 99% of I/O from flash, we're trying to be hyper dense. So we want the ability to have hundreds to 1,000 VMs in a single 3U node. That really helps with that dollar per VM cost that people seem to be after. Sometimes we have customers come to us and say, we have been given this dollar per VM that we have to spend. The way our budgeting has been decided by management is we've got X dollars per desktop, and we now need to build an infrastructure around that. Can you help us? That's one of the things we've also been successful in. It's the same high available 5 nines, fully redundant architecture you'd expect in any enterprise class storage appliance. And really at the heart of what we do is this VM-aware concept, this file system that we essentially built on our own from scratch purposely with VMware and taking advantage of flash storage in mind. So we provide this end-to-end latency feature we call instant bottleneck visualization that's going to help you identify when there is a performance problem in your VDI environment. And you'll know exactly where it is, right? Is this on the replica? Is it on an individual user's disk? Is this due to some linked clone problem? We'll be able to pinpoint exactly where in the infrastructure your end user is having the issue, and so it basically gives you that leg up on going to resolve it. We also do something that's quite interesting in the fact that we automatically align misaligned I/O. And this was a problem that kind of existed in prior versions of Vue. This was actually solved in Vue 4.6. We're all the way up to Vue 5.1 now. But what's nice is if we detect misalignment on a VM, we'll automatically resolve that. We'll automatically realign the I/O. It's a hands-off thing. You don't have to do anything. This is also one of those features that gives back performance to that VM. In addition, we have some advanced snapping and cloning capability that will now really integrate nicely with a newer version of View. And we can touch on that a little bit later if somebody has a question about that. From a simplicity standpoint, this is also a big strength that we have, and it's one that, frankly, customers love. When we compared ourselves against sort of the traditional approach, general purpose storage, we realized that there was a lot less overhead steps or just architecture involved to setting up a VDI deployment. So if you looked at, say, a 500-seat desktop installation, right, and you looked at, so this is actually a reference architecture on the left from a general purpose storage vendor. They basically want 3 different shelves of disk, 3 different types of disk. They want SATA drives, SSD drives. They want 15K fiber channel. They want you to slice and dice things up into 8 different LUNs, build 3 different data stores out of this, and ultimately purposely place replicas, linked clones, and user data disks on different places within the array. So you've got some storage architecture and complexity, and then you're basically taking advantage of some of the features that the View Connection Broker brings to purposely place desktops in certain areas. What's nice is with Tintri, it's literally a large, high-intelligent bucket for your data. You can basically put your VMs in the VM store, and the file system is going to figure out where the parts need to be and when, right? So you can essentially put a replica in there, create a bunch of linked clones, and not have to worry about purposely placing them in various parts. What this really helps with as well is that economic promise, that meeting that dollar per VM, that dollar per desktop that sometimes you're tasked with as an infrastructure guy or as an admin. We believe we can actually decrease the dollar per VM, increase, that performance as well, all by doing it with a simple approach and a dense approach, and basically a VM-aware approach. What's nice is we've actually had customers turn into sort of the internal hero. We have several different VDI customers who have either kind of stumbled on their VDI project where they realized that after putting in Tintri they had the investment there to unleash VDI, or we've had customers who have essentially purposely went after us for VDI, saying we have a small project, we want to get this off the ground, we haven't been able to with traditional storage. So we've had several customers that have ultimately been able to rescue stalled projects and kind of take advantage of the investment they may have already made with VMware licensing, View licensing, that was kind of petering out due to an infrastructure problem underneath. And what's nice is we don't just stop at VDI. We really are all things virtualized. So across our customer base, this is just sort of a snippet of it. We're helping with all different sorts of things, from big SQL Oracle type databases to vCloud Director, VDI, and just regular general server virtualization. If you do want to find some more specific information about our VDI, our solutions, there's a link for our solutions guide. You can always contact us to request a deeper dive demo where we really go into the system, show you exactly how everything works, and kind of explain the file system. And I'd also love to field questions. If you guys have questions now, I would be more than happy to kind of go in and answer some of the questions.
Thanks, Justin, for presenting that. That was really informative. This is Mark jumping back on here, and I've been fielding several questions throughout the presentation. Justin, there are 3 specific questions that have come in, although I'm happy, obviously, to take more questions as we go on here. You may have answered one of these as you were presenting, but I'll just go ahead and start from the top, from the first question in. One of the attendees has asked about modeling and planning for VDI, and the question specifically is traditionally we've had difficulty predicting workload and modeling IOPS for our VDI deployment. Do you have recommendations or approaches or tools that can help with that challenge?
So what's nice is there are a whole bunch of tools already sort of in the industry to do this, right? There's VMware tools that can do capacity analysis and workload analysis and give you back some information. And then there's some other tools from Liquidware Labs or Lakeside Software that are specifically VDI assessment tools that will actually go and monitor physical and already virtualized workloads, give you back throughput numbers, give you back I/O numbers, give you a very scientific look into what your current workloads are. And when you have information like that, it's very easy to start building a scientific sizing scenario. What's nice is that on the Tintri side, we actually really allow for flexibility, right? Because we handle some of the bursty nature very well, you can actually afford to be off by a little bit, right? So if you looked at your sizing data and we put, together an architecture, and all of a sudden that project turned into a couple hundred more seats than you had planned for, it's not going to be something where you have to rip and replace or tear down or rebuild an architecture that we had already decided on based on number of disks and LUNs. Typically, there's flexibility, kind of an elasticity in the Tintri, both from a performance and a capacity standpoint. So being off either, hey, we ended up seeing more users than we expected, or we got a new application that's a real resource hog, and we've got to now put that in the base image, it's not going to force us to kind of tear down the storage architecture and rebuild it. That one high-performance, high-intelligent bucket will kind of gracefully handle the extra workload you may not have been planning for.
Great. Thanks, Justin.
Sure.
The second question, this I believe you answered when you mentioned we had integration with Vue 4.6, but the question is, do we have VAI integration with Vue 5.1?
Yeah, so it was a great announcement recently by VMware. When they announced Vue 5.1, they also announced support for some VAI offloads into Vue. So VAI is the VMware API for VMware API for array integration. Essentially what it does is it offloads certain ESX tasks to the underlying storage. So this is great because what it's actually going to do is allow us to create sort of a hardware version of a linked clone natively on Tintri, but do it all through Vue. So basically through Vue, we're actually able to take advantage of some of the advanced cloning capabilities that Tintri has at a VM level. And what we're doing here is we're actually able to provision rapidly hundreds of desktops that normally would take Vue Composer with regular software link clones a lot longer to do. So that integration's there, works beautifully, and we have customers who are absolutely loving it.
Wonderful. Thanks again. And the final question from the audience is, how does XenDesktop work with Tintri?
Another great question. So I've been kind of heavy talking about Vue, but XenDesktop being the other big VDI connection broker and composer out there definitely works fine. 90+% of the deployments of XenDesktop I see are actually on vSphere as the hypervisor. Most of our customers are comfortable with the vSphere hypervisor. They think it's a superior hypervisor. So if you're asking about XenDesktop on vSphere, it's definitely doable, right? To Tintri in the end, it's just seen as a VM. So the connection broker piece is perfectly compatible, works just the same as Vue does.
Great. Okay. Any other questions from the audience before we wrap up with a closing comments? Any pressing concerns or questions for Justin that may have arisen? It was that complete of a presentation, Justin. Must have been
excellent.
We covered everything.
So yeah, if people want more information, I would recommend them checking out the solutions guide or going online and requesting a demo. It definitely will give you the one-on-one attention specific to your environment, specific to your questions, and we're able to dive a lot deeper into the actual solution at that point.
Absolutely, and Justin, I want to thank you for going through the presentation. That was quite informative. And to echo Justin's comments, If you have additional questions about how Tintri works with VDI, VDI challenges in general, or more broadly about Tintri's solution and our approach to virtualization, please visit our website. You can contact our sales team or request a demo of the product or download some of the white papers and case studies we have in the resources section of the website, where we address not only VDI but test and development environments, workload consolidation, and a number of other use cases. So we look forward to you visiting the website, and please do feel free to contact us. And thank you all for attending. Oh, it looks like we have one question from Stephen, and before we go, let me pull that up. Stephen, your hand is raised, and go ahead. You're live. Perhaps not. Sorry, Stephen. I'm trying to connect you here, but it looks like you had raised your hand for a question. Oh, he says, sorry, no microphone. Okay, so if you could go ahead and type your question, we'll go ahead and answer it. The question is, would you recommend Tintri clone or view clone for deploying multiple VMs?
So typically it comes down to what the use case is, right? So there's all different types of desktops. There's full thick desktops, full clones. There's linked clones. Those come in both persistent and non-persistent. So ultimately what I would do is kind of work with the customer and say, what are we trying to deploy here? What type of desktops? There really isn't a bad scenario where using the VCI offloading would be a negative. If you're talking about actually doing clones from within Tintri and then importing them into a floating or a manual pool, there are some pros and cons there. If they're for persistent desktops, it's actually a great use case. If it's for something other than that, using the VCI integration may give you more control ultimately because it's controlled through view versus through the UI. But it ultimately depends on what you're trying to accomplish with this particular pool of desktops. Are they persistent? Are they non-persistent? Do you want them to be, full, thick provision desktops? A lot of it comes down to those type of questions.
Thanks,
if it's just for a pure speed of deployment, Tintri linked clones, right? The Tintri cloning is actually going to be much, much quicker. And not necessarily. What's interesting is our clones don't suffer the same sort of performance hit that linked clones do because they're done native to storage at the hardware level versus through this sort of snapshotting offload that vCenter is doing. So there is some performance gain as well to the native integrated clones native to Tintri.
Stephen actually asked, do they also auto-populate in vCenter?
Indeed, yes. If you make a clone native to our UI, it'll automatically be added back into inventory. What's nice is we can even give you the ability to apply vSphere customization files against those. So if you have your vSphere customization files loaded into vCenter, you can apply your desktop customization files, and it will re-IP it, re-host name it, and re-add it back to the domain, as well as whatever other things you're putting in that quick prep type file.
Great. Okay. Well, Stephen, thank you for the answer. Looks like we're good there. And we actually have to end the webinar now, but we appreciate everyone's attentiveness and your questions. And we, again, look forward to you visiting the website and contacting us if you have any questions at all. Thank you very much. And thank you, Justin, again, for
Sure.
going ahead and
thanks, Mark. Thanks, Stephen, and everyone else on the phone.
You bet. Okay. Have a good day, everyone. Bye-bye.